Good afternoon. My name is Ben Roll. I'm an application engineer here at Ally PLM Solutions. I'd like to welcome all of you to our Lunch Bytes session. For those of you that don't know, these Lunch Bytes sessions are held once a month. They're designed to explore the capabilities of Solid Edge that are often overlooked. In today's session, we're going to look at the translators. So we'll look at what files you can open and save out as. So just a quick look at what we're going to go over today. First, we're going to look at what formats can be opened and saved out. We'll also look at what file type you should ask for when you're getting files from vendors. Next, we'll go over the options for importing files. Then we'll take a look at the Geometry Inspector tool. We'll also look at what file formats can be exported and the options that are available when exporting. And then last, we'll take a quick look at the migration tools that are available and what's required to run those. See, here we have a little chart that shows the different types of formats that can be opened and exported inside of Solid Edge. A few things to take note on here with STL. It comes in as faceted data, so it's just kind of a dumb surface. Can't really do too much of anything with it. So if you're opening that, you have to open it in the ordered environment. In order to do that, if you automatically have Solid Edge set up to open in synchronous, you'll have to change that in the Solid Edge options before you open the STL file. Next thing to notice is CATIA translator. There are two separate translators. One is for version 4 and one is for version 5. And both of those are add-ons that have to be purchased separately. They don't come with Solid Edge. So now we're going to answer a question that I'm sure a lot of you have, and that's, I'm getting files from a vendor and I need to know what format should I ask for. Well, here you go. First off, you should always try and get native files. For instance, we can open files from SolidWorks and ProE and Inventor, so if you can get those files, you should get those first. If not, you can get Parasolid or Step or iGest. Those are the preferred formats to import. There are a few things to note when you're importing as far as the number of part files and the size. So if you're importing 600, 700 parts or more, what'll help you is if you turn off the import do not save parameter. So you'll set that to off inside of the INI file for the translator. So if you don't know, an INI file is where they save the options that you set when you run a translator. So each translator will have its own INI file, and inside of that they'll have options that you can set. Another thing as far as memory, if you're opening large data sets, about 100 megabytes in size, you're going to start running into operating system limitations. So you should be careful how big the files you're importing are. So now we'll take a look at some of the different file formats and some important points that you need to know about those. So first we're going to look at step files. And with the step files, something that you might not know is that you can actually open them up as text files, and when you do that, you can just open those in Notepad and you'll see this user info. That's stored in there. So if you, instead of opening up the part, you can open it up as in a text editor, and you can see who created it and the timestamp and useful information like that. Another option in here is the export AP 214. What that does is that will include construction, solid geometry, and the color information, as opposed to if you don't have that checked, it'll just use AP 203, and that's intended mainly for single part definitions. As far as the memory requirements, the general rule of thumb for the step translator is that it's going to require approximately 12 to 15 times more memory than the size of the file. So for example, if you have a 100 megabyte file, then you're going to need about 1.5 gigabytes of RAM to open it. As far as how long is this supposed to take? A lot of you import the file, and you're sitting there and it's cranking away, and you have no idea to know, okay, has it stopped doing stuff, or is it still running? How do I know how long this should take? You can try and gauge it. For a step file, it'll take about 8 to 10 seconds per megabyte. It could take longer. It's just kind of rule of thumb. And later when we talk about the log file, there's some things that you can go in and you can check, once it's done, or if it has failed, what do I need to do to make this come in faster? So we'll look at that later on. As far as the SCT file, those are also, you can open those as text files and you can view the same information. One thing to know when you're exporting to AutoCAD or Inventor, and you're exporting as ACES, you need version 7, and that's the latest version that Autodesk will support. So if you do a version later than that, it's not going to be able to be imported into AutoCAD or Inventor. Also, and this, I've even seen it here, when you're importing data and it's running through the Parasolid kernel, it needs to lie inside this box. So there's this imaginary box that represents the model space that'll be imported, and it's about 500 meters on each side. So you have a total box that's 100 kilometers around on each side. So if your file, and that box is centered about the origin. So if your file is outside of that box and you save it out and that you go to open it in Solid Edge, if it's outside of that box, it's not going to come in. You'll just get an empty file because your model was outside of that model space, so it wasn't brought in. When you're dealing with JT files, when it comes in as faceted geometry, like I said with the STL file, that can only exist in the ordered environment. You can't open it into synchronous. So, you have that facet body, and it's just a surface that's defined by triangles. And that means that, you're not going to be able to use the synchronous tools. That's why it has to be brought in to ordered. So, you can't locate faces or edges or anything like that on a faceted body. You just hover over any part of it and it'll locate the entire body. So along the lines of that, obviously any of the commands that require, faces or edges, those will fail if you try to use those on a faceted body. And, if it contains a facet body, if the solid edge part does, then the commands that add or remove material from the base feature are just going to be disabled. Now, as far as Inventor, you can directly open Inventor part or assembly documents inside of a solid edge, assembly, part, sheet metal, whatever environment you need to open them in, just by using open. So that's something new with ST4, that now you can directly open Inventor part files. But in order to do that, you need to have a copy of the free Inventor viewer on your computer. So all you have to do is go out to the Autodesk website, and then you can download the free viewer and you'll be able to open up the files. However, the Inventor files have to be saved in version 6 or later in order to be opened inside of Solid Edge or even inside of the viewer. So now we'll look at some of these import options. You'll see here I have a screenshot of a general import option screen. So first we're just going to look at the 3 options that you have. The first one is to generate a log file, and that's going to contain any of the warnings and information about the files you imported. And later on we're going to look at, how do you read this log file. Below that you have this heal and stitch option, which is just going to take any free surfaces that it can, and it'll heal and stitch them to create a solid body. Below that you have simplified geometry, and that'll do 2 things. It'll replace any B-spline geometry with simplified analytic geometry. In addition to that, it'll take any half cylinders that share a common center line and merge those together. So basically what it's going to do is take B-spline geometry, and if it can change it into, like a plane or a cylinder, some simpler shape like that, it will. You notice this dialog box is a little different, but it still contains those options, the actions on import, and the output folder that was on the other screen. This is, the most options that you're going to have inside this window. Some of them have a little bit less when you import, some of them have this. So right now we're going to look at the actions that are available on import. So the first one there is to stitch surfaces, and all that's saying is that you want to take any surfaces that are separated but they're within 1 times 10 to the 5th meters, or sorry, 1 times 10 to the negative 5 meters, and you're going to stitch those together to create one surface. You have a similar thing with the Boolean solids. What that's going to do is that'll take all the solid bodies that are together and it'll form a single solid, and it'll insert that as a part copy. Below that you have the option to group curves into a single part copy. That's exactly what it says. It's going to combine all the curve data into a single part copy. You also have the body check. That's just saying, I want to run a body check on this model. By default, that's going to be turned off, but you can turn it on if you want. You also have the make base feature option, and that's going to tell Solid Edge that you want to take the imported solid body and make that a base feature for the Solid Edge model. Notice we also have down below the scale override values, and that's just saying you want to apply a scale to this model. You also have the output folder option, and you can set that to either be the same as the input folder where you're getting the file from, or you can set it to a different folder on your computer. And what that's saying is when I import this model, it'll go ahead and it'll create the assembly if you save it into an assembly, and then all the part files, or it'll just create the part file or whatever file format, if it's sheet metal or part or assembly, and it'll put all those files into this directory. That's where you specify what directory you want to put it into. So now we're going to look at the log file. So like I said, you're importing like maybe a step or an IGES file, and it just seems to sit there. Or, it takes a really long time to finish, and you're kind of wondering, okay, what's going on here? So what you can do is if you turn on that log file option, it'll generate a log file. And there's not a lot of information in there, but there's probably enough that it'll help you to see what's going on. So there's 3 important areas in the log file. There's the reading of the file, processing the data, there's simplification, and there's the healing and sewing. So if the file's taking a long time to process, then what you can do is you can disable the enable internal healing, and that's also located in the INI file. Or if it's taking a long time to simplify, then you can disable the simplification option. Same thing, if it's taking a long time to heal and sew, then you can turn that option off. And in a little bit, I'll go ahead and I'll show you a log file and point out where those areas are. Another thing to keep in mind is the templates. So if you do any custom stuff with your templates and you change the location of the template and it can't find it, it won't be able to import. So in the registry, there's an area where you have all the templates stored and it tells you what it's pointing to. So if you modify the location of the template files, you have to define the new path to those. And if you modify the template names, you have to provide those names into Solid Edge. And you can do that by just running the Set Default Templates option inside of Helpers. And that'll run through and correct the names if you've changed them. So now we're going to look at Geometry Inspector. What Geometry Inspector does is it's a tool in there to inspect the model. So you'll see you can inspect the active model, or you can inspect only selected components. And you can check those for faults or for small entities. If you check for faults, then it'll just go through there looking for faults. If you choose small entities, you have an option of what entities you want to look for. So if you turn that on, you can do faces and edges. So edges is pretty self-explanatory. It's going to look for an edge that's shorter than the the value that you defined there. If you turn on faces, you have a few different options. You can have it look for small faces, so it's going to look for any face that fits inside of a sphere with the specified radius. You can look for slivers of faces, which sliver is a face that has a high aspect ratio and a small area. So it'll look for those. You can look for spikes, which have a high aspect ratio and a small area. The difference between those and the slivers is that only a portion of the face will fit that criteria, not the entire face. And you also have the by area, which will search for faces that are smaller than this given area. We also have JT format, which there's a couple different options here. When you save it out, you can select if you want all the documents, just the part documents, or the assembly documents only. If you choose assembly documents only, that'll save out the structure of the assembly, but it won't contain any of the parts. It'll just be like a bill of materials. You also have the document structure if you want it to be a single JT document, if you want it to be the assembly and the parts, or if you want it to be everything, the assembly, the subassembly, and the parts. You can also select to simplify certain bodies. So you can, once you have your model, if you've created simplified parts or simplified assemblies, you can select to use those inside the JT file instead of the full design. You can also choose a few options. You can include the precise geometry. You can remove unsafe characters, which I have up there listed what characters it'll remove, and it'll replace those with an underscore. You can translate the visible parts, the visible constructions, translate inner part copies, which if that's not selected, then the inner part copies that are in your assembly or in your part will not be exported. So you have to have that checked if you want inner part copies to come through. You can translate the document properties so that you can see those. You can delete any unused JT part documents. So if you've already created it and you save it out again, if you removed a part, it'll remove that from the JT file. You can also save out the PMI data, and if you turn on the save PMI data, it will automatically turn on include precise geometry, because that's needed in order to save out the PMI. On import, you have similar options to what I showed earlier. You can choose to, if you have precise geometry turned on, you can import that for the surfaces and that for the curves. You have your stitch options, the Boolean, body check, make base feature, link the file. Some of the options when exporting, just to go over a few of them. For example, Parasolid, you can choose the version. You can choose if you want to export solids, sheets, wires, or only what's displayed. When it comes to step, I already showed you this dialog earlier when we talked about that. But here you have what solid bodies to export. You can export just the wireframe, the surface models, or the manifold solids. Same as you've had with others, you can export solids, sheets, wires. You have the translation options to generate a log file or to export as that AP214. And you have that user info that shows up when you open it as a text file. IGES, that has an export wizard. So these are just some screenshots of that. Unfortunately, I don't really have time to go into detail with the options available, but it'll kind of walk you through, what bodies you want to export, the export options. It'll walk you through all of these. And you can go into help and it has some more information, or if you have any questions, feel free to send us an email to ask. We also have the save as flat option, and I'll go ahead and I'll show that here in a minute. As far as saving out a flat pattern of a sheet metal, you can save it out as a DXF if you need to. Last, we have the migration tools. And just a real quick slide to show what those are. What it requires is that you have one seat of the native CAD program installed, not necessarily on the machine, but on your network that you can get to. And the migration tools are also only available in the 32-bit version of Solid Edge. And inside of Solid Edge, if you go to your Start menu, you can get to the Getting Started under the Data Migration, and that'll give you help for using these migration tools. So real quick, I mentioned the step file, how you can open that inside of a text editor. Here I just opened it inside of Notepad, and you'll see right up here is the information. Here all those fields were filled in as unknown, so unknown is showing up for all that information. But if whoever saves it out fills that in, you can open up inside the text editor to see all that information. We also have the log file for when you're importing. So here it'll tell you how long it took for the translation, number of bodies, and here I turned on simplify, so it tells me how long it took to simplify that. So you can look in there and see how long is it taking to do these various actions, and then you can adjust when you import it again which option you turn on to save you time when you're importing it. The last thing we wanted to look at was the save as flat. So you'll see here I have just this basic sheet metal part. If I come up to the application button, I can go to save as, and I can save it as a flat. And you'll see I can save it as DXF, sheet metal, or a part file. And I'll just go ahead and select the face and the edge. If you have a flat pattern already created, you can select that to use. And then you see the dialog box for save as flat. I can go into the options like I showed in the PowerPoint, And here I can select the version of the DXF. I can select which layers I want to display and which layers I want to export. So you see I can just turn those off right here. I can also map the bin data, and I can map the fonts. So if I don't like the font, I can change it to a different font for what the AutoCAD one is. I just hit OK, go through the options, and then I just save it out as a DXF. All right, I'd like to thank all of you for your time. Looks like we might have run over just a little bit. I know it was a lot of information to take in, so we will have the replay posted on YouTube, but if you have any questions, feel free to contact us. I have my contact information up here. Like I said, we're going to post this on YouTube. All of the replays of all of our Lunch Bytes are on our website. They're also out on YouTube. See here, if you have a smartphone, we have a barcode here that you can scan with the barcode scanning app, and it'll take you directly to our website. Once again, if you have any questions, feel free to contact us. Have a good day.